Last video, L shared with guys about the change rule of the inner ring contact angle and outer one with the rotation between the spindle and the bearing during machining. Today, L will show guys how the change of contact angle of bearing affects the rigidity of the spindle under different preloading methods. As we can see, the axial rigidity of the spindle when the position is preloaded will decrease slowly with the increase of the rotational speed at first, and then increase rapidly after a certain extent. The early decrease was mainly caused by the change of contact angle. The subsequent rise is due to the centrifugal force pushing between the inner and outer rings and the rolling ball, causing a sharp increase in rigidity. For fixed pressure preload, its spring force is almost constant in terms of the property of spring itself, so that the contact angle change plays a relatively vital role in the whole process, throughout which the axial rigidity is almost in decline. In other words, the rigidity is continuously decreasing. Maybe some people have doubts, since the axial rigidity changes with the increase of rotational speed. How about the radial rigidity? Considering that when a machine tool is working, the bearing is mainly influenced by the radial cutting force. Actually, for both radial and axial rigidity, there is a fixed ratio. No matter how the contact angle changes, when the axial rigidity of spindle changes, the radial one will also change. For instance, if the axial rigidity reduces a certain percent, the radial one will also decrease by the same proportion. At this time, perhaps another question occurs to you, as is seen from this picture. The rigidity in fixed pressure preload affected by the change of the contact angle will decrease with the increase of rotating speed, which will lead to the decrease of axial rigidity and radial rigidity. The decline of rigidity at this state. Whether there will be the lacking of rigidity, which will result in vibration ripple when a machine tool is working. When it comes to position preload, the axial rigidity of spindle will increase with the rise of rotating speed by the interaction of the contact angle and the centrifugal force. So, will the additional rigidity cause the spindle to overheat? Regarding how to explain the phenomenon above or how to avoid and rescue them, I will share them to you next time.